What is up, amigos? Today we're talking about how aerodynamics affects a car's braking, and this may not seem like a very intuitive topic, but once we go through it, you realize just how important it is and how intuitive it is. So let's say we have the road here, and we have a car, two wheels, and we're just going to draw a very simple car. And we have the wind coming in this way. Now let's say the car is moving at 100 kilometers per hour, and we want to brake. Now, in terms of the braking, what amount of braking should the front wheel do and what amount of braking should the back wheel do? Well, it depends on how much loading there is to begin with on each of these wheels. So let's say there's a 50-50 split between the two. That means the front wheels should do about 50% of the braking and the rear wheels about 50% as well. But let's say there's now a 70-30%, which is fairly extreme. But let's just say that. Now that means that the rear wheels should only be braking about 30% of the amount, whereas the front wheels should be braking about 70% of the amount. And the thing with braking is the car is the most efficient in terms of braking when the wheels are maxing out how much they can brake. So let's say the front wheels are braking 70%, but the rear wheels are only braking 20% of what they can be doing. Well, that means that the car is not really braking as quickly as it can. So how does aerodynamics affect this? So to begin with, we have a car and we might design it so that the front wheels will brake 70% and the rear wheels 30%. But as soon as we start to go quite fast, the car might start producing lift, which a lot of cars do. They are quite aerodynamic. They're quite airfoil shaped. So that means there's going to be a lift force here. Now, often the lift will not be exactly through the center, so it won't affect the front and rear equally. The front will be affected differently to the rear. So let's say the front is affected and we now have a drop of 60%. So we have this reaction force now because the front is being lifted up a little bit. Let's just say the rear is the same. It's not necessarily the case, but just for simplicity's sake, that's the case. So now, let's say in terms of loading, the 60% here, 30% here, and 10% is taken from this lift. And we were to brake, and we were to try to brake at 70% for the front wheels. Obviously that's not going to work because the front wheels are going to start to skid then, and they can start to lock up as well because the friction here is not enough to help the braking. It can't withstand the braking. So likewise, if we have another car, and this time the rear wheels here, we have, again, let's say it's 30% and 70% to begin with, which is very extreme, but anyway. And when we start to brake, what will actually happen is the car will start to lurch forward a little bit, as we've all felt. So this is going to result in more loading at the front and less loading at the rear. Couple that with the lift, that means that the rear wheels are often not even 30% either, it might be 20%. And with the lurching forward, this might be up to 70% or even 80% now. So this is actually the worst of both worlds because one, the rear wheels, you can't produce the 30% braking here that we have designed for, and if you do, they'll start to skid. Here, we've only designed this wheel to produce 70% of the braking, when in fact we actually do 80% here. So we've got 10% here, which we're missing out on. So that means this car is not braking nearly as fast as what it can. Now, what about this speed? How does that affect the braking? Well, obviously, the faster we go, as we know, the more lift these objects will be producing because lift is proportional to the velocity squared, and so it's exponential. So that means the faster we go, the more this problem becomes exacerbated. And what that means is when we start to design a car, should we design the car to brake under a very low speed or a very high speed? Well, intuition tells us it should be at a high speed because obviously braking is more important, generally speaking, at higher speeds than lower speeds. So that's why we need to sort of err on that side of caution. That means at low speeds, the car is quite inefficient in terms of braking. And that's how aerodynamics affects the car's braking system in terms of this loading and the dynamics. So if you like this video, make sure to like it. And if you want to see more like this, click the subscribe button. And if you want to learn more about this kind of thing and other aerodynamics, check out a course by JKF, which is they go into motorsports in terms of the aerodynamics from a fundamental point of view as well as practical point of view. It's a very nice course, very comprehensive. You can find it in the link in the description. And also check out a book by Joseph Katz called Automotive Aerodynamics. You can find that in the link in the description as well. And we'll see you in the next video. Peace, amigos.